conversation today. Bill, thank you so much for taking the time to join us today.
Great to be here, Wanzi.
So let's just dive right in, right? For investors on the line who might not be as familiar with the company, can you start off maybe just giving a quick overview of the company?
Sure. So Velo3D is a leader in metal 3D printing through the laser powder bed fusion process. We supply a full stack hardware-software solution that enables customers in the space, aerospace, manufacturing technology, and energy industries to print high-value complex metal parts. So our focus is on high-value metal parts that legacy 3D printing technologies could not print. These are parts that have complex geometries, low angle overhangs, internal channels, and the like, that for legacy 3D printing technology was not something that they were able to accomplish. And so what we're doing is we're converting those. So those parts had to be made through casting and forging, and in many cases making multiple parts and putting them together into an assembly. So we are focused on converting those parts from legacy metal manufacturing techniques to 3D printing. We can produce parts that are up to 1 meter tall and up to volumes of 10 cubic feet. Our Q3 revenue, which we just reported, was 19 million, 51 million year to date, up almost 3 times over year to date 2021. So that's a quick snapshot of who we are.
Yeah, no, that's helpful, Bill. So maybe let's just talk about the industry for a quick second. And when you think about the 3D printing industry, we've sort of it's been a decade since I think Forbes highlighted this, and there was a lot of focus on the consumer side of things, which eventually didn't quite play out the way that it was projected to. But you guys play in a very different space, and so can you maybe talk about the broader industry, how you look at the addressable market, and then just in terms of competition, how you view the competitive landscape?
Sure. So we play in, as I mentioned, those applications. If you take a step back, the original idea of 3D printing was that you could print a complex part in one pass that might otherwise might be an assembly that required multiple different parts that had to be cast or forged. And so the promise of 3D printing was that you could push a button and you could produce this part in a few days that might otherwise take might have a lead time of a year. Unfortunately, the 3D printing technologies that were available at the time couldn't handle the geometric complexity or the angles or the internal structures that those complex objects frequently entail. So that held the industry back. We developed a technology that could handle all those complexities. We also focused on the production market because we wanted to have customers that would scale. So we focus on production customers in space, commercial aviation, defense, energy, semiconductor, recently automotive, and so on and so forth. So industries that use high value parts that are often mission critical part in the system. For example, in a rocket engine, something like the impeller on the turbo pump that supplies the engine with fuel. Or parts of the combustion chamber, or in a jet engine, a fuel injector. So we focus on those parts that are geometrically very complex, but also have a major impact on the performance of the system, because that's where our technology has the highest value. In terms of competitors, we're really the 3D printing business is very fragmented. We do have there are those legacy competitors who use earlier generations of the technology. As I mentioned before, what we're doing is converting parts to 3D printing that previously couldn't be 3D printed before. So we are really focused on applications where we are alone in marketplace. So we don't see any significant changes there. There are other players who use different. So I think that's how we think about it. That's how we see the other laser powder bed fusion players. They generally don't have the ability to produce parts with the complexity and, importantly, the quality that are required in the types of applications that I've described. And then you have the players that use other binder jetting technologies, for example, where the focus, those technologies can't produce parts with the temperature resistance and strength of laser powder bed fusion. So they're more focused on high volume, low cost applications. And that's not something where we really play. So we're sort of, if you think about one end of the spectrum, you have the high value, high performance, high temperature, complex geometry parts where you couldn't do 3D printing before. That's where we play. On the other end of the spectrum, you might have binder jetting where, you're focused on customizing large volumes of simpler parts that have a lower performance specs. And in the middle, you might have the legacy laser powder bed players who are generally focusing on simpler applications that their technologies can accomplish. So you've got to think about it as a series of different pockets. Obviously, we believe our market has a tremendous amount of growth potential because the aggregate high value metal parts market is $100 billion, of which only low single digit proportion is addressed through 3D printing today. So we think there's a very large conversion opportunity out there.
Well, where do you think that penetration is, or that is, and call it 5 to 10 years? I don't know if 5 and 10 are quite different, but
it's difficult to say. As I mentioned, we grew our 9-month year-to-date September revenue is 3 times what it was in 2021. So we've had a very high growth rate. We think the total laser powder bed fusion hardware market is about $1 billion currently. Our 9-month revenue is 50 million. We've guided to 75 to 80 for the year, so we're still a very small proportion of that. Although we believe we're the second largest player. It's really difficult to answer the question. It's going to be multiples higher than where it is today. Whether it's 3 times higher, 5 times higher, 10 times higher, I really can't predict, because we're converting one application at a time, and so it depends on how many new applications come along that where customers want to go 3D printing. It also depends on how quickly they scale into production. So we've seen SpaceX go from one system in 2018. They have now more than 20 of our systems, and have obviously scaled rapidly into production. And depends how rapidly other customers go down that path. So I know it's going to be multiples, but I just as I said, when you're in low single digit penetration, you can double every year for a long time and still get a small number.
Sure. Well, one of the things when I first started to follow your company that struck me as impressive was the endorsement that you got from SpaceX. Maybe you can talk a little bit about what you do for them. Why is it that other companies, your competitors, have not been able to do what you've been able to do? And what is it that's unique and differentiated about your technology that allows you to actually make these products for SpaceX? Well,
this goes back to long before I joined the company. I want to say it's 20 discussions in 2016, 2017. They came to us and said, can you print this part? And it was a part that they wanted to produce through 3D printing, but were unable to do that on any other system because of its geometric complexity. And we looked at it and we said, yeah, we think we can. And we printed it and went away, printed it on our system, went back, showed it to them, and they were very impressed. They bought a machine, and then they decided that they wanted to use our machines in not just for demonstration research purpose, but for production. So they ended up buying 10 of our Sapphires. They were so happy with the consistency and the quality that they moved all the parts that they could onto the Sapphire. And then they came to us and they said, we'd love to move more of our production onto more parts onto your systems, but we can't fit them. Can you make a printer with a larger build envelope? After some negotiations, we entered into the contract for the initial production of the Sapphire XC, and we've now delivered 10 of those systems to them. They're performing very well. So to answer your question, what can we do that others can't do? We can do the geometric complexity that they need. We can do and this is very important, the consistency of quality. One of the big features of this market is that customers are moving into scaling for production. And in order to scale for production, you need to have very consistent quality. Every part has got to be done the same way. Because we have a full stack solution that analyzes the part, develops the lasing strategy, executes the lasing strategy, and records the status and quality of the machine, of the build at every single one of thousands and thousands of layers, we're able to deliver identical quality of part across hundreds and hundreds of thousands of different parts. Other systems in the marketplace require more intervention and more individual parameter setting by the operator. So as a matter of their architecture, they can't get the same consistency. I think of our system like an iPhone. It's a completely enclosed, full stack, closed loop technology or closed technology system. There are very few operator variables. That the flow software does all that for the operator. Other players' systems require more manual intervention by the operator in setting parameters, and that introduces variability into the build process that is not present in our system. So that's one of the important things that we do. In addition to the geometric capability, that's another very important thing that we bring that's critical for a customer who's scaling production. You can send, if you're using contract manufacturers to produce parts, as long as they have a Velo machine, you can send the same build file to half a dozen different contract manufacturers, and you'll get an identical part. And that's not possible with other providers. So I think, for the folks that use contract manufacturers, that's an important differentiator. For those players who have multiple machines, they know they're going to get consistency of quality across builds.
Yeah, that's helpful. So when we think about the other competitors in the market, what is preventing them from doing some sort of closed loop adjustments like you guys do? Obviously you spend a lot of time, energy, investments, IP know-how into the process. So there is a time advantage, I would think, that you guys have. But why haven't the competitors been able to figure this out?
Well, these are companies that have been in business for a long time. They have their way of doing business, which is more of an open source system when it comes to the software, the slicing and process control software. I can't really comment on why they have done it differently. I can tell you that we have a proprietary process. We have proprietary hardware. So we have a process technology and a hardware stack that are specifically developed to work with each other. We have a contactless recoder, and we have a process that leverages that recoder. The process, the lasing recipes, the hardware, the recoder, and even the signature that the process leaves in the metal part are all patented. So you can't do any of that without infringing. You can't replicate our approach without infringing our patents, which obviously we're not going to tolerate that to occur. We have a very extensive patent portfolio, so we think that fully protects our process and our approach. So I think, in addition to just legacy approach, I think our patent portfolio is a major obstacle.
Okay, that's helpful. Can you maybe just talk about sort of as you look at the company and the growth strategy, what's your regional exposure currently? Where do you see the opportunities in terms of growth areas?
Sure. So we're predominantly U.S. Currently. It's a high percentage of sales. We've begun to make sales in Europe. as we mentioned on the call in the recent the third quarter call we just did, we've landed two marquee customers in aerospace in Europe, so we think that I think that Europe is probably the region that has both the scale as a marketplace. It has the engineering companies that are good candidates to adopt 3D printing technology. So I would say that is, after the US, that's our next largest potential market. We have distributor relationships in Japan. We sold systems there. That market is, I'd say, probably slower to adopt than Europe, so probably will take a bit longer. And we've also sold a system in Australia, and we have several significant potential opportunities to sell systems there as well, into their space, aerospace, general industrial market. So those would be, of those three, Europe is by far the largest potential. We've also had some dialogue in places like India and Southeast Asia, which are possibilities. But Europe is where we have we have direct sales folks in all three of those regions. But we have a much larger sales footprint in Europe because that's where we see the largest near-term potential.
But I just want to go back to tech differentiation for a second, and just it might be helpful for investors on the call to understand what you mean by support free and sure. Sort of being able to print something like that. Can you maybe? Yeah, okay, that's perfect. Yes.
Hold up this part, which you see in some of our investor literature. So this is turn around. It's a cross section or a half of a small turbine, and if you can get up close to the camera, you can see that there are internal cavities here, and you can see that some of them have very low angles. So legacy technology, as these parts are printed, they're printed by a process of firing a laser at a bed of powdered metal that melts the metal, and then the metal cools and solidifies, and as it cools, it wants to warp. So a traditional technology would print additional material around some of these structures to hold it in place and prevent it warping. The problem with that is, as you can see from this part, many of those cavities are fully enclosed. So if you put additional scaffolding, if you will, in the form of additional metal around these parts to keep it in place, you can't get it out in post-processing. So the part becomes useless. So our technology has the ability to print this part as is. In fact, this was printed on our machine with no supports at all. And so for a part that has complex geometries, you can see there's some low angles here down in the corner. For a part that has a complex geometry or a complex internal channel, that support-free capability, not only to print it, but to print it with very low porosity and a very high quality that's needed for a high-stress, high-temperature part, is essential. If you can't do it, you can't make the part. So that's the key differentiator, one of the key differentiators that we bring to the party. The ability to do that, to do it consistently across dozens of machines and hundreds of parts. And that's a benefit of a fully, I'll use the term closed-loop hardware-software solution. So our software is designed, and our process are designed to work with our proprietary hardware. And the hardware enables the lasing process and vice versa. And as I said before, that process and that hardware is patent protected. And there's also, as you can imagine, printing a part with this kind of complexity, with no supports, no scaffolding, just doing it layer by layer, is a very sensitive, sophisticated process. And so there's also a lot of know-how in being able to set up the machine and the parameters to do that right time after time after time. So we've learned a lot over the last 4 years of being having our systems in customer production that has enabled us to do this process with high reliability. Yeah, so the barriers to entry, if you will, are the process technology, the fact that it's all patented, and all the experience and know-how and trade secrets that we have accumulated over the past 4 years, and all of the hundreds of lessons we've learned about how to do these parts. It's not a simple flip the switch and forget process.
Yeah, no, that's very helpful context. So just in that part that you just showed us, Bill, how long does it take to print a part like that?
That's a fairly small part. That might be 12 to 24 hours, something like that. Yeah, so that's something that I don't think that's a multiple day part. I don't know for sure, but
yeah. And I'm just wondering, one of the things that's different, I guess, in 3D printing versus something like a semiconductor market is just the rate of increase or improvement in process technology or things like that. So that sort of increases the speed, right? But more law in semis. But as you think about 3D printing, do you think that the speed of printing that part goes up materially over the next several years? Is there technology behind that can accelerate that?
Absolutely. Yeah, we expect that we will see significant scaling and speed. To give you an example, in 2018, we introduced a 2-laser Sapphire printer. In 2021, we introduced an 8-laser Sapphire XC printer that's 4 times faster. So it's a 4x improvement in 3 years. So we're continuing to work on product development. There are ways that one can improve speed through the laser and process technology that we're working on. Obviously, you can, by building a larger system with more lasers, you can increase speed as well. Yeah, we would absolutely. This is an early stage technology. Our first printer was introduced to the market in 2018. So if you think about the first few years of the semiconductor business, there were rapid advances, and we're in a similar situation here, where with every printer we put into the marketplace, we continue to learn how to print to improve reliability, and we're continuing to work on improving speeds. So yeah, that's going to bring costs down, and is going to expand the market even more than where it is now. The Sapphire XC reduced the cost of printing by about 2/3 relative to the Sapphire, so that makes it cost competitive in a much wider range of applications. And we've seen that with the market response to the product, and our order book and number of XCs ordered has exceeded our expectations.
And just for the audience, it might be helpful to give some context on how much your machines cost to your customer, and frankly, the fact that they're willing to pay this amount shows that there are not a lot of alternatives in some ways to make the product in the way that they desire. So maybe you can just touch on sort of how much it costs your customer to acquire one of your machines.
Yeah. So the Sapphire XC, the standard XC, is the list price of $3 million, and the Sapphire is a list price of $1.75 million. So it's a significant investment, but it's as I said, we've seen very rapid adoption of the Sapphire XC in particular. That's grown very rapidly since it was introduced at the very end of last year.
Right. So what we're talking about is parts that are being actually used for end-use applications. These are almost being put in mission-critical applications, like putting it in a rocket engine or a jet engine. I mean, we're talking about things where you need accuracy, reliability, you need fault tolerance, all these elements of working in harsh environment. These are not prototype parts that other makers maybe sell machines for a couple $100,000, and you have parts that are prototype. This is a very different market, a very different approach. You guys have taken a very deliberate approach of tackling sort of the toughest problems that are out there for 3D printing. That's
a good summary. Yeah, our parts are used in high temperature, high stress applications. Rocket engines, jet engines, large energy installations, things like pump impellers, downhole equipment for the energy industry, shower heads for the semiconductor industry, and recently die inserts in the automotive industry. So that's something where the reason our technology is used there is that we can print larger cooling channels into the die insert, so that the die can be the die tool can be used faster than for other applications, than other die inserts or die inserts that are produced by other applications. So, if you think of a die casting insert in an automotive plant, it's a very high stress part of the machine, and it's used for creating high temperature metal parts. And so that's another example of a very critical application that has a big economic impact for the customer. And it's important in an automotive plant that the process works right every time, as its quality is such a focus. So high temperature, high strength. We use nickel alloys, copper alloys, aluminum, titanium, all the high spec, high strength metals. We specialize in those, and as I said, we're focused on the high value, most complex metal parts, because that's where our technology has its greatest value to customers.
That's helpful, Bill. So just in terms of, if you think about selling these machines, $1.5 to $3 million machines in this economic environment, can you just help us think through how sensitive it is to that to the economic environment, and secondarily, what does the sales cycle for these products look like?
I don't think it's particularly sensitive to the economic environment. It's more about the customer having an application where 3D printing can make a significant difference to their economics. And for the most part, our customers are large companies where, for an important piece of capital equipment, $3 million is well within the capability to afford it. And if they can print something 4 times faster, or you can create a die insert that enables you to operate the plant 20% faster, you're going to easily recoup that price. These are not sort of discretionary consumer purchases. These are large-scale pieces of industrial equipment that have a well-defined use case with attractive economics. So, we haven't seen particular economic sensitivity. I would say one of our key markets is aerospace, aviation, and defense, and those are all markets where those are markets that are doing well now. They're not particularly economically sensitive. Particularly the space market tends to be populated by companies that are well funded. There are big companies like SpaceX that have government programs and have such a strong position in the market that they're not economically sensitive. In the defense world, we've seen a high priority placed by the U.S. government on hypersonics development. We've also seen a strong push for production around weapon systems. That all is funded by the U.S. government. It is not sensitive to economic cycles. The aerospace market is doing well. The energy markets are doing well. So we are focused on markets that are not particularly economically sensitive, and where the ability to deliver the application with a very short lead time and high quality makes a huge difference, because the lead time for castings can be 12 or 18 months. The other issue that we hear a lot from customers about casting is that as many as 20 to 30% of what they receive from the casting supplier might be non-conforming to the design. And with 3D printing, because of the status of the machine at every layer, exactly what the quality of the part is coming off the system, and our successful build rate is dramatically higher than in casting. So all of those are advantages where if the customer is particularly a well-funded organization, and those advantages, and they have a development program that has a timeline that's important for them to meet, then we bring a lot of value.
Yeah, that makes a lot of sense. Can you just talk about maybe the manufacturing of your machines as well? How you go about that process?
Sure.
Have you had any supply chain challenges with respect to that?
Yeah, so we source components and sub-assemblies from a variety of suppliers, both some of which are domestic, some of which are offshore, and we do the assembly of the system in Fremont, California, and testing and final testing and final process validation all happens in Fremont. We don't fabricate any parts; we source everything. So in terms of supply chain, we have had our challenges. As I mentioned on the earnings call on Tuesday, we did miss some shipments this quarter because we couldn't get certain electronic parts. Or we could get them, but they arrived so late in the quarter that we weren't able to complete the assembly and particularly the testing process. So there's an assembly, there's a calibration, and a testing process, and that's followed by a reliability build. And if you get parts in week 9 or 10 of the quarter, there just isn't time to get all that finished. So yes, we have had our challenges. We're working with suppliers on staggered deliveries, and we're working with suppliers and helping them source the components that they need to make the assemblies that they send to us. So we're hopeful that through better planning, dealing, and if you set up a supplier to deliver a certain quantity of a part, you tell them I want 3 of these every month, then the supplier has good visibility on the production needs far in advance and can organize themselves to make sure that they have the parts that they need to deliver to us. So we've tried to, we've entered into longer term staggered delivery contracts with a view to ameliorating the supply issues that we've had.
Okay, that's great. We're almost out of time, so maybe this would be a good place to ask you, what are you most excited about in terms of both product roadmap and customer opportunities as you look out over the next few years?
Well, I think we're most excited. We've in the last couple of quarters, and I think we'll continuing into this quarter, we've landed a number of very large strategic customers who are buying their first machine, and these are customers who have the potential to buy dozens of machines, and because if we can become a core part of their production program, they could be. We saw an example with SpaceX of what happens when you become a core part of the production process of a big company, and we've sold our first machine to a number of large customers recently, and we're very excited about what that could bring. On the product roadmap, I don't have anything I can talk publicly about there, but we're continuing to do a lot of work on improvements. I'm excited about our potential to really start to popularize our technology in Europe, and we have a number of new space customers here in the US that are very innovative, fast-moving companies where that are rapid adopters of 3D printing technology. So as these companies grow their businesses, we expect to grow with them. So we've got multiple significant opportunities of different shapes across our portfolio, and I'm really excited about all of them. We grew very rapidly this year, and we're seeing increasing recognition of the value of our technology, and converting new applications like the automotive die casting thing is something where we announced it a few months ago, and we've already got a major auto OEM has bought multiple systems. So things can happen quickly.
Perfect. Unfortunately, we're going to have to leave it there, but for all the folks who tuned in, if you have any follow-up questions, please do reach out, and we'll do our best to try to get those answered for you. And Bill, this was super helpful, very, very clear on sort of what the differentiation here is. Very exciting time. Wish you all the best, and speak to you soon.
Thanks, Ramsey. Much appreciated. It's good to be with you.
Yeah, likewise. Thank you so much, Bill. For the investors on the call, our next session starts at 11 a.m. Eastern, roughly 10 minutes or so. We're looking at financial intelligence through AI and machine learning. It is with the CEO and founder of AlphaSense. A lot of you on the buy side might already be using it. We here on the sell side also use it, so kind of a topical thing to talk about. And please also remember to use the question dialog box as well. Happy to take questions real time. Thanks so much, and see you in about 10 minutes.